My name's Keith Weber. I'm the GIS director here at Idaho State University. I recognize quite a few of the names of the participants who have joined in for our live tech talk. And I want to talk to you today, share with you some information that I'm calling the hidden gems from ISU's GIS TReC. That's the Training and Research Center. It was founded in 1998, and I guess officially I am the founding director for the GIS TReC. And the research center itself, as you can see here, has focused on understanding land cover change using GIS and satellite remote sensing technologies. I have over nearly 80 professional publications, over 1,100 citations in over 2 decades of research on a research program. And detecting land cover change is really, really simple. We can detect change very, very easily with Landsat, multispectral satellite imagery, Sentinel satellite imagery, those sorts of things. It's easy to detect change, but it's far more challenging to understand why things are changing on the landscape. And so I've had about 2.5 decades plus into this research program, and that's really the most difficult question to answer. It certainly does keep a person busy trying to figure out why are parts of our landscape changing and other parts otherwise very, very similar perhaps, but they're not changing. The mission here at the GIS Center is to facilitate, I'll say, wise decisions, land management decisions, through the application of geospatial technologies. And one of the things that we pride ourselves in is we transform spatial data into actionable information. And what we're looking at here is what's called the data to wisdom pathway or pyramid. There's lots of data out there, and we work with geospatial data all the time, but it's actually very interesting, challenging sometimes, but also very rewarding when we can transform that data into information that then becomes knowledge for someone, and when it's correctly applied, that is wisdom. Well, that's in a nutshell. But let's continue on here. I truly believe that GIS, if it's not used, not applied in any way at all, then it's as pretty much good as garbage, pretty expensive garbage, actually. We've got time that was devoted by the GIS technicians and specialists and analysts and all these other folks producing the data, analyzing the data, and really thinking about understanding the data, this intellectual effort as well as money, that's wasted if the data and information is not used. But GISers themselves are not decision makers. The decisions that we make are pretty mundane, pretty simple things. We can decide to have a hamburger for lunch today, or we can decide to have a salad. That's about the extent of our serious decision making. But we're not the ones who decide on land management policy, zoning, and so on and so forth. There are others that do that, but they need to rely upon, and oftentimes do rely upon, spatial data to make those decisions. So it's important to share our spatial data and our information. But of course, it can't be used. No data or information can be used if we're not sharing it to begin with. So we have to make sure that we're doing it. But then, even if it's shared and no one knows about it, the data still will not be used. So I'm sharing it. I'm letting you know about it. And I hope that you'll be able to use it or work with others in your organization who can make use of it. Maybe you'll be the person who helps facilitate the use of some of the data coming out of the GIS Center and the information and actionable information coming out of the GIS Center. That would be just great to see happen. And if you ever do that, then it'd be great to let me know about that. So let's talk about some of what I call our hidden gems. Pretty simple stuff, I think. Topography. That is a very important base layer to so much of the GIS work that we do. Whether you are working in a city organization and need to um, understand how water is flowing over and across the city into the stormwater systems, or a new subdivision, or you're working in the natural resources and need to understand erosion, water-based erosion. Topography is so important. And so we have developed, and I'll show you this, we'll talk about our topography image service. We'll talk also about our LiDAR image service. Well, that's also topography, but as you know, LiDAR is far more spatially resolved than some of the earlier topography data that we've used in the past. NDVI. NDVI is the Normalized Difference Vegetation Index, and we have developed an NDVI baseline, that's what we call it, image service. That's probably our most exciting part that I want to tell you about today, and we'll get there after we walk through and talk about the other two hidden gems. So let's jump into this. Topography of the Western United States. This is the spatial extent of this individual data set that we are providing as a streaming image service. It's available both in a REST or Esri image service format, as well as a WCS or open image service format, WCS or REST. It's based on the USGS NED, National Elevation Data Set. And it is wall-to-wall seamless data across all 11 Western states here. And those 11 Western states were selected because that is the study area for our NASA Recover project. NASA Recover, some of you may know, is our I'm the PI, a principal investigator on this project funded by NASA, and Recover, in a nutshell, is a post-wildfire decision support system. And we can talk more about that. Maybe I'll do a presentation on that in the future. But across this whole area, it is filled with 10-meter pixels, 10-meter cell size. It is, again, a seamless wall-to-wall layer for the entire Western United States. And you can connect to that and make use of it. Just stream it right in, no download necessary. Well, you know, elevation is okay all by itself, but there's more to topography than that. So what we've done, and what I've done, is I have embedded raster functions into the image service. And those raster functions include slope, calculated in degrees, slope, calculated in percent rise, aspect. We've also embedded, or I wrote a function that will convert the elevation z value, which in natively is in meters. It'll convert that instantly into feet. So if you're accustomed to or need to use feet as that z value, just use that function. And there's also the hillshade. That's what we're looking at right here. The LiDAR image service, okay, yeah, LiDAR is also topography. And until we have wall-to-wall LiDAR coverage across those 11 Western states, I'm going to continue serving that topography image service. That's the drawback, of course, with LiDAR is it's expensive, it's large, it's just huge data. And of course, we don't have 100% coverage across the Western United States. Across the United States, we don't have 100% coverage across Idaho. So what we're using, though, is we're using best available 1 meter spatial resolution, bare earth LiDAR elevation data. Now, all those source data have been hydroflattened whenever it's possible. Well, to hydroflatten LiDAR data, we have to have break line data. Oftentimes, the break line data are things like the large bodies of water, cliffs, prominent cliffs, road grades that are elevated, those sorts of things. If the vendor that collected and delivered that LiDAR data provided what we call break lines, then the output product will be hydroflattened. That's a little bit of an improvement on the standard bare earth digital terrain model. And then we'll also do a pit fill, relatively simple routine in ArcGIS Pro and other GIS software that will look for holes in that digital terrain model and fill them if they have a large difference between the surrounding individual pixels. So literally, if it looks like a pit or a well, something like that, then that pit fill routine will fix that. We do that so that a person can use these data more or less out of the box for flow modeling. And most of the spatial analysis that you would perform in ArcGIS Pro or other software can be performed with the image service. You don't need to download the data itself. You can perform most of this stuff with the streaming image service. And we have a similar list of embedded raster functions in this LiDAR image service as well. Slope in degree, slope in percent, hillshade, conversion of elevations from meters into feet, et cetera, et cetera. And all you have to do, of course, is turn those on in ArcGIS Pro. This is the current service, LiDAR service coverage as of, I guess that's Monday when I did this screenshot. We don't have 100% coverage around the state of Idaho. There's little bits that are missing between project areas up here in northern Idaho, some fairly large chunks that are missing here and there. These all here in southern Idaho, by the way, will be or should be filled in relatively soon once we have received full delivery of the FEMA 2018 LiDAR collection. That stuff is still coming in. And so once we have that all delivered, we will have 100% coverage down here, still working on these things. And by the way, I'll throw this out. There's a lot of talk starting now about revisits, reacquisition of LiDAR data in certain parts of Idaho. What parts of Idaho should be reacquired? Well, if you've got some ideas, areas that you think should be reacquired with new data because maybe the existing LiDAR was done in 2010, we have a lot of that, 2010, 2011. Well, now we're talking at least a decade old, and maybe something else has happened in that same area. Maybe a wildfire, landslide, avalanches, anything that could have changed the surface there, including subdivisions and so on. If you know something, feel free to, you could email me and I can make sure that that information gets brought over to the elevation technical working group. But I digress just a little bit. Let me keep going here. I want to talk and spend some time talking about the NDVI baseline image service. This image service uses Landsat 8 OLI NDVI data. Lots of acronyms there. That NDVI again is Normalized Difference Vegetation Index, and more or less it tells us about how actively growing vegetation is inside each of those pixels. And there are lots and lots of pixels across this same study area. And as you can imagine, based on what I've told you already, this baseline image service was created also to support the NASA Recover post-wildfire decision support system. The pixels here are not as finely resolved as our topography layer, not 10 meters and certainly not 1 meter, but it uses the standard Landsat 30-meter pixel size. What did we do to make this thing? Well, we acquired NDVI data over a decade across this entire study area that is actually over 18,000 scenes of data. And when we sum up all the pixels in that data cube, over 1.1 billion, that's correct, billion pixels inside this data set. We then scaled, and this is a little nice tip for the GISers out there. We scaled that NDVI data by multiplying it, each of those scenes, by a value of 10,000, and then converted the pixel bit depth into a 16-bit signed integer bit depth, which then the result of that is we didn't lose any important information. What we did, though, is we dropped the size of that data cube literally in half. Instead of being about 3+ terabytes in size, it dropped to a little under 1.5 terabytes in size. And as you can imagine, when you end up serving that amount of data as an image service, smaller is by far better. So then all that data, all those 18,000 plus scenes were added to a mosaic data set. We added what's called multi-dimensional capabilities. In other words, the date, year and date, obviously, of when that imagery was collected. So we enabled time on this, saved the results in a cloud raster format, CRF, and then from that, we created an image service. That service can be used in a web map, or even better, stream it into your desktop to do analysis. Couple of things that a person can do with that NDVI baseline. We have a point-based web app. When you launch that NDVI baseline web app, it'll look just like this. And as you click in different places, this little pop-up will appear, and it'll tell you that the mean NDVI at that pixel throughout time, throughout a decade, was 1,256. Now remember, this has been scaled by a value of 10,000. So if you're really accustomed to NDVI data being -1 through +1, just do a little bit of math in your head and you'll get this figured out. We'll also notice that we show the median, maximum value over time, standard deviation, and you, of course, can scroll this down to see even more statistics about what that point that you just clicked on. If you need more information apart from point data, then it's advised to use the desktop GIS. We have a tutorial on how to do that, several pages that you can step through to learn how to use the NDVI baseline. You can extract a temporal profile. There was some problems with it yesterday. I'm not so sure if some things have changed in ArcGIS Pro, and it may no longer support this. But what I'm most excited about for the NDVI baseline is that we can drop a polygon onto our NDVI baseline layer. Let's say it looks like this. And I can extract zonal, what we call, that zonal statistics out of ArcGIS Pro, or even in the old days, ArcMap. And we can really understand what has been going on inside that polygon. So we created this that we could then understand what has happened in the past within a fire perimeter. But you can do the same thing with any polygon that you're interested in. It could be a crop field. It could be a certain area in a forest, a certain area in some wildland urban interface, whatever it happens to be. That, I think, is a really powerful tool. You understand then what has happened as a long-term, decades-long baseline at that area. And then, of course, you can see how are the current conditions, what's going on today. And if there was a disturbance there, a wildfire or flooding or whatever it happens to be, you can see how well that same area is recovering to pre-disturbance conditions. We have some what we call byproduct services. We've already generated these same 11 states. We have wall-to-wall coverage of the mean NDVI baseline. Again, that decades long, what is the mean value for every one of these 30-meter pixels? What is the median value, standard deviation, maximum value, as well as a 95% confidence interval, the upper bounds layer and the lower bounds layer. I have bolded the word median there because that's the one I recommend people make use of. Because if we think about this, if somewhere inside, an area that we're interested in, let's say right around here, if there has been a disturbance inside that past or that decade, then the NDVI values shortly after that disturbance occurred will be really, really low, very, very low, extremely low. And those very, very low values will pull the mean down very, very low, right? Much lower. It'll affect that mean quite a bit. That's kind of an extreme value. However, by using the median, you're going to get obviously the middlemost number, and it will automatically filter out, just the way the median works. It'll filter out those extremely high or extremely low NDVI values. So that's why I recommend that median in this case is used instead of the mean value. But of course, a person can use whatever they like when they're using this NDVI baseline service and the byproduct layers. And all of these are made available as services as well. Accessing these layers, you might be wondering, okay, you just showed me all this stuff. Now, how do I get at it? Well, you can download a little zip file. There is the URL. There is a QR code that'll download that for you. Inside that zip file, there are layer files as well as URL links for each of our little hidden gems. Go ahead and make use of this, download that stuff, and yeah, use it as you need to. I'd love to see people make use of this, and if you ever need some help using it, maybe better understanding it, whatever it is, just let me know. Most of you know my email address, but if you don't, there's my email address. And you can learn even more about the research going on at the GIS Center by visiting that link right there. So that wraps up what I wanted to talk about, to reveal and share our hidden gems here at the Idaho State University's GIS Center. And I'd like to open the floor for any questions in the time that we have remaining.